Hello, welcome back again. Ya, ke nna ka lebitsa ke nna Dr. wa ga Tlhongwane. I hope le sa thabile ka moka. Yes, today re lebella for the hyperbola, exponential and inverse functions. So with functions, remember the first functions we did was parabola. After parabola, we did what's this other one? The cubic function. Now we're doing hyperbola, exponential and inverse. Right, sharp. Let's start with hyperbola. Hyperbola on a Cartesian plane, it must be drawn. Oh, bless me. Sorry about that. On a Cartesian plane, x and your y. Then let's consider your hyperbola's form. It's in this form. It's a all over x minus p plus q. Right? Then your this x minus p is equals to 0. The denominator, as we solve it, is going to be x is equals to what? P. P to the other side of the equal sign. Then this we call it our this will be our vertical. This will be our vertical asymptote. This will be our vertical asymptote. Meaning, asymptote it's a point at which your graph doesn't touch, and then our horizontal, vertical, this one, and then our horizontal will just be y is equals to q. Remember, we take even the sign, even here we take the sign, that's why we do it this way. Then this will be our horizontal asymptote. That's where your graph doesn't touch the horizontal line here, somewhere here or at the bottom, or vertical this here, or the negative side. Right? And that's it, it's just a line. And then from there, what else needs to be explained? What needs to be explained is our a. If your a is greater than 0, meaning it's positive, it means your hyperbola is increasing. Your hyperbola is increasing. Then as we read from left to right, it will increase from here going up. You see it's going up, it's increasing in that fashion. I'll explain in details. And then when a is it's less than 0, meaning it's negative, it's decreasing. Right? Sharp. So let's quickly draw a hyperbola. Let's say we have y is equals to a, which is positive, let's say 1 all over x minus 1 plus 1. Right? Then if we have, in this case, if we have this, we can know that this, our vertical asymptote, our VA, will be x is equals to 1, because we take this and it's equals to 0, p to the other side, x becomes 1. And where 1, it's here 1. Then we have a asymptote here. We show it with dotted line as it goes down at 1, meaning our hyperbola doesn't touch at 1. Then our horizontal asymptote, which is y is equals to, is just q, and q is 1. And check, it's positive here, it's positive, meaning even this one is positive. Then we just take it as it is. If it was negative, -1, we'll just have y is equals to -1. But here it's positive, y is equals to positive 1. Then one on the y-axis, it's here, somewhere here, something like this. Then we know we have our two lines of asymptotes, vertical and the horizontal one. Then now a tells us that our hyperbola is positive, meaning it's increasing from the lower part. Then from the lower part, it's going to be like this, and then it's going up, it's going to go like that. It's increasing, but it doesn't touch the asymptotes, so just get close by. So this is our hyperbola, this one. Then we're going to determine the x intercept and the y intercept. We know how to find the intercept. If it's x-intercept, we let y equals to 0. Then we put 0 here on our equation and solve for x. And then when we look for y-intercept, we do the very same, but interchanged. X now is equals to 0. Then we put 0 here and solve for y. let's just get the y-intercept. The y-intercept is very easy to get. If we put 0 here, this become 1 over -1, then it becomes -1. Then -1 plus 1 it becomes 0. Then the graph it cuts at 0 and 0. But for now, we just do it. We just want to implement, show you how it's done. Then, as I said, if here is supposed to be like that, right? And then if it's negative, our a here, let's say we need to draw y is equals to -1 all over x minus 1 plus 1. Then the asymptotes are still the same. It still cuts here, and then it still cuts there. The asymptote p and q, right? And then now it's negative. Then if it's negative, our graph will be on this side, not cutting our asymptote, and on this side, on the second and the third and the fourth quadrant. Why? You see now this is decreasing. Our graph will start above going down, it's decreasing. This start here from left to right, start here, it's going up, it's increasing. The effect of a on the hyperbola graph. I guess I've explained everything so far. Then we move to the exponential graph. Exponential graph. Exponential graph. Exponential or function or graph. It has a form y is equals to a times b to the exponent x, where a is just it's just a number, a and b are just a number. For instance, let's say we have y is equals to 2 to the exponent x, meaning our a is b, and meaning our a is 1 here times b, which is 2 to the exponent x, as it's written there. Then our exponential graph, because it's positive, the a is positive, you see a is positive, it's gonna be like this, and always cuts at 0 and 1, always, as our y-intercept, right? And then it is going to have an always the distance between this and the asymptote is always 1. Then the asymptote is on the y-axis, always there's an asymptote there. Why? Because our a is positive, you see it's increasing. When our a is negative, let's say we have y is equals to -2 to the exponent x, meaning the graph will be like this. Why like that? Always as well, cutting at 0 and 1. Always 0 and 1. Why it's like this? Because a is negative and our function is what? Decreasing. A is negative, our function is decreasing. A here is positive, our function is increasing. You can see if you read from left to right, this is going up. If you read from left to right, this is going down. But it doesn't cut here at the asymptote. Then that's more about it. Then let's say you have y is equals to 2 exponent x plus 1. All this plus, it means you have the original graph of 2 to exponent x, it shifts 1 unit up. Then is this one and it goes 1 unit up. Then this point is going to come here. This point is going to come there. All the points going to go up. Then your line will be like this. Your new graph will be like this. And remember, the asymptote was at the x-intercept, x line, the x-axis. Then it's going to move 1 unit up. Then the asymptote is going to come here. Meaning this part will never cross the y is equals to 1 line. Makes sense? Same applies. Let's use a different color. When you have y is equals to 2 to the exponent x minus 3. All it means, the original x 2 to the exponent x, which is this one, the black one, it goes 3 units down. Then this point is going to move from 1 to 0 to -1 to -2. And all the other points will come in that fashion. And then we're going to have this graph looking like that. This is 3 units. This as well as 3. The difference is 3 units. Even here is 3 units everywhere. Then you see that asymptote was cutting at 0. Then it's going to come at 3 now. while this is 0 and -2. I guess we are all understanding what I'm trying to elaborate. Same applies with the negative here. If we plus 1, meaning the very same, it goes 1 unit up. If we minus 1, it means it goes 1 unit down. If it's a plus 1, it goes 1 unit up. And until we understand. So I've just explained hyperbola and exponential function. Now we move over to the inverse function. Yes. And yeah, with the inverse function, it's denoted inverse function is denoted by this symbol where it's negative f to the negative y. This shows that it's an inverse if it's written in this manner. Then step number 1 in determining the inverse, you first swap. Wherever you see x, you put y, and wherever you see y, you put x. Then the second step is to do what? Solve for y. Make y the subject of the formula. That's about it. So let's say an example, let's say you have y is equals to minus 3x plus 2. This is a straight line, right? Oh, I have to make a video on straight line. I haven't touched on straight line. Sharp. If you have y is equals to minus 3x plus 2, that's a straight line. If you're finding the inverse of this function, first you're going to say swap x and y. So where you see y, you put x, and then where you see y, where you see x, you put y plus 2. Then the second step says what? Solve for y. Make y subject to the formula. Then you take these 2 to the other side. Then it's going to be x, still in here, minus 2 is equals to minus 3y. But you don't want minus 3y, you only need y. Then you divide by negative 3. You divide by negative 3. Even here, you divide by negative 3. Then in here, what's left? This will be negative 3 over negative 3. It's 1. Then it's going to be 1y is equals to, this is going to be negative x over 3. There's no way you can simplify, just write it like that. And then negative and negative becomes positive 2 over 3. So this, you can just say it's equals to x to the exponent -1 to show that this is an inverse. That's about it. When you find an inverse function, always you do that. Let's try another, the last one. The last one can be y is equals to 4x plus 3. Then as well is the same. Where you see x, you put y is equals to, where you see x, you put y plus 3. You take 3 to the other side, you just solve using the second method, whereby it's equals to 4y. You divide everything by 4, you divide everything by 4, you divide everything by 4. In this side, then you'll be left with x over 4 minus 3 over 4 is equals to y. So this is equals to your inverse function. Right? You can get inverse function on as well on an exponential graph, whereby you just say this is an exponential graph given, and then you swap. Where you see y, you put x. Where you see x, you put y. Then now you solve the second step, solving here. Because you have an exponent, you have to introduce things called log. I'm going to do a video on logs, log, and then you introduce log in both sides. And then one of the loss of log is that if you have an exponent of, if you are having a log of a number that has an exponent, the exponent can become a coefficient. Then you can end up with this. Don't worry, I'm gonna put a link or to a video that I did logs, and then this will make sense by then divide by log 2, you divide by log 2, then you end up this log 2 cancels log 2, you end up with y this side, and then this side you end up with log all over 2x. I will make a video on how I eliminated one of the logs and how is that important on the log video. Thank you so much, and this will be equals to your inverse for the exponential graph given here. So that's how we calculate inverses, and then that's about it. But lastly, we can look at this thing called one-to-one function and many-to-one function. One-to-one function, it simply means for each and every y that you get, you only have one x. For instance, in a straight line, this is y is equals to mx plus c. For each and every y, if this is y1, you're only gonna get this x1. There's not gonna get any other x. If you have y2 here, you're only just gonna get this x2. If you have y3 here, y3, it will only give you this y3. Then that's a one-to-one function. You can check it using the vertical line. You can check it using the vertical line test. You can check it using the vertical line test, whereby you see for each and every y you get, it only touches once. You see, as you go, it only touches once. This is the vertical, it only touches once. Then it's a one-to-one function. And then with one-to-many function, let's say you have a parabola, right? You have a parabola here. If you have a parabola, you can use you can use the vertical line as well. Test the vertical line test. You can use the horizontal line test to check, right? And as you use the horizontal line, you see for this y here, it touches twice. It has many x's. So many-to-one function, it's where you have many x's for one y. For instance, if this is y1 here, you see it's gonna have this x and another x here. And then if you move up the horizontal line, with the horizontal here, you see it's gonna still have two. So this is one-to-many using the horizontal test. Same apply here. Even if you will use the horizontal test, for each and every y you get one x. For each and it only touches once. Here it touches twice. My bad. You see, here with the horizontal test, it touches how many? Twice. This side and the other side, twice. For each and every field it touches twice. You see, here it only touches once, because it's, then this is a one-to-one, this is a one-to, this is a one-to. I mean, the horizontal test is used to determine which function is it. Is it a one-to-one or is it a one-to-many? You only have those two, one-to-one or one-to-many, right? And yeah, then that's about it. And you can as well use, I was using the vertical. Let's the importance of using a vertical test. This is a vertical, not a horizontal. A vertical test, it must always touch once. You see, it touches once here, once, it goes up once. If a vertical test touches a graph twice, that graph, it's not a function. That thing, it's not a function, it's just a relationship, it's not a function. So we can further do what? We can further look at this. No, not that. We can just draw. We can look at the cubic function. So with cubic function, when we use the vertical test, you see it's only touching once, it's only touching once, it's only touching once, it's only touching once. Then a cubic function, it's as well a function. That's why we call it a function, right? And even on the cubic function, we can use the horizontal line test to test whether it's a one-to-one or it's a one-to-many. Then you see here it touches 1, 2, 3. It's a many to one function, it's a many to one function, it's a many to one function here. And then after this turning point, then it becomes one to one function, one to one function. But the bottom line is it's among these two. Then that's about it. I hope everybody understands and we cleared the vertical line test and the horizontal line test, the inverse, how to get it, the hyperbola, how to get it, and the exponential function on it. In the next video, we will do the straight line function and include other important factors such as the midpoint, the gradient, and the point of intersection. I hope you don't miss the following video. I'll be hoping to see you there. Thank you so much.